All right, now we're going to go in reverse. Now, if you watched the previous video, I think I had a branch not equal 6 and 5, but then when I did the example down here, I said 7. Again, voices in my head, craziness. I've been in and out of mental hospitals, and so you know that I, say very weird things, and I also make lots of mistakes. So if I said 7 down here and it was a 5 up here, I apologize, and that's the correction. Okay, so I walk up to you on the street and I say, this is the encoding for a jump instruction. Okay, the opt field contains a 2 in decimal, okay, which means it contains 000010 in binary. But then I got all these bits. What am I going to do with them? All right, well, what I need to do is tell you, so somewhere there's going to be a jump and then ham loaf. Okay, and then I ask you, what is the address of the instruction ham loaf? With these two bits of information, so I say that I issue the instruction J and then a label, and then I give you the encoding of the bits, then I want to tell you, or I want to ask you, what address does it go to? And it's unconditional. What's the next address of the instruction? Well, I need to tell you where this is at. So, this is at 0xDEAD010F. I can't do F. I'm going to do C. Okay? Dead 10C. Okay, now we have all the information. I know that my new address is going to have the 26 bits of the instruction field, of the target field of the instruction. So I know that I'm going to copy down these 26 bits. Okay, so we'll have 26 bits. We need 6 more bits. Where are those 6 bits going to come from? First of all, we know that the last 2 bits must be a multiple of 4, therefore they must be zeros. So now we're missing 4 bits. So this is the absolute address of where we go. Where do we get the first 4 bits? I am missing 4 bits, and I need to get 4 bits. Well, it comes from where you're presently at from the jump instruction. Now, you say, why can't I just tell the full 32 bits of the instruction? Well, it's because we only have 26 bits in the opcode. There is a different instruction that we're not talking about that allows you to jump to an address from a register. It's called JR. We're not dealing with this. We're only dealing with the jump. So these 4 bits come from wherever the jump originates. And it's going to be a D. So a D is a 1, 1, 0, 1 is a D. Yep. So this here is 1101. And so then, if we look at this whole thing, that's an address. So there would be some address, and then that would have the label ham loaf. And this ham loaf, maybe it's an OR instruction. Okay? What is the address of this instruction if it were in memory? Okay? So memory starts at 0, 0, 0, 0, 0, 0. What is the address of this? Well, okay, I don't want to write it in hex, but this converted to hex would be the address of whatever instruction Hamloaf is labeled. There just happens to be an OR here. So when I jump to Hamloaf, that's how I get it. I need to find 4 leading bits and 2 trailing bits. The 2 trailing bits are always 0. The 2 leading bits are always the same. So, to answer, hopefully, the question that one student had is, what's the difference between a branch and a jump? Well, it's called, or the jump is not only always taken, but the jump is pseudo-absolute, okay? We're actually encoding the bits of the target instruction. We're actually saying, where physically in memory is it, okay? And you have to know that address. Before, when you did the branch instruction, I could give you the code, and the code is enough. You don't need to know where the code is, you just need to know how many instructions forward or backwards the target for the branch is. But for a jump, you need to know in memory exactly where it's stored.